Hello, and thank you for clicking on this help video. So let's see what we got here. So in this example, we want to determine the end behavior of the following polynomial functions. So in this example, we don't have the standard form of the polynomial. What we have instead is the factored form. So our polynomial function f of x equals to a times x minus c to the power of 1, or not power of 1, but c minus 1, and then x minus c, our second constant, and then x minus the third constant. And we're going to keep on multiplying these until we have of all, okay? Now, the correlation between, again, this factored form and the standard form is that for the standard form, the degree of the polynomial, this first term right here, correlates to what this value is, and the degree is going to be the sum of these values. Basically, how many of these things am I multiplying together? And then, of course, I have all the other stuff that I'm adding again to this until I end up with my constant. So to using the leading coefficient test, I have to determine what is this value going to be. Well, from the factor form, I can determine that and get the standard form by looking at the leading coefficient, which is 1, so 1x, and to determine again the power, I simply add up all of my factors. So here I have 1x minus 5, I have 2x plus 2's, and I have another 4x plus 2. So that's going to be a total of 1, 2, 3, 4, 5, 6, 7. So 1x to the 7th power is going to be that first term. And then all the other terms, like I said, are irrelevant. Like I mentioned in today's notes, all the other ones are irrelevant, and I don't care about anything else other than that. So let's see what's going on here. What's the end behavior to our graph? Starting off with the right side, since this number is a positive number, that means that the right side is going to be pointing upwards and that the right side rises. Now, since this number, the exponent, is an odd number, that's going to describe what's happening on the left side. So compared to the right, since the exponent is odd, that means that the left side is going to move in the opposite direction. So the opposite of rising is falling. So our left side will fall. So we do the same thing with the second example. Here, our leading coefficient will be 5. So as in standard form, f of x will equal to 5 times x. And to determine what that largest exponent, the degree of our polynomial, we're going to add our multiplicities. Again, add how many factors we have of each. So 4 plus 1, 4 plus 1, that's 5. And 5 plus 2 more is 7. So another thing to the 7. So this is going to behave the exact same way. Since this number is positive, that means that the right side is going to go up. And since this number is odd, opposite, the left side is going to go in the opposite direction. It's going to move down. So our left side falls and our right side rises. I hope you found this video helpful, and I appreciate you watching.